Good day, everyone. I'm very glad to inform you that I have completed a certification in Ekahau, which is ECSE design, nothing but Ekahau Certified Survey Engineer. This certification is very useful and it is mainly for the Wi-Fi design and survey engineers. And using these Echo products, you can easily build, design, analyze, and troubleshoot enterprise-wide Wi-Fi networks. Ekahau offers various products. The first one is the Ekahau AI Pro software, which I am going to discuss shortly. And there are several other products and software provided by Ekahau, namely the Ekahau Sidekick 2, the Ekahau Survey, Ekahau Insights, Ekahau Analyzer, Capture, Cloud, and Private 5G. All these softwares and devices are used for designing a well-defined network. A great network starts with a great design. Okay, so to design a great network, it is essential for you to try and use Ekahau AI Pro tool and other tool that is associated with the Ekahau ecosystem. So the first one I'm going to discuss here is about the Ekahau AI Pro, and this is the download link for the Ekahau AI Pro. I will share the link in the description, and it is available for both Mac and Windows users. And this comes with a license key, and only if you have purchased a valid license, you can access this application. And in some cases, they provide a 7-day free trial. And there are three options available in adding the floor plan. Either the floor plan can be a PDF, can be a JPEG or PNG format, or it can be a AutoCAD file. Okay, so I'm going to click the add. I'm going to select the last two files here and click open. Here, floor 1, floor 2. Okay, two floor plans has been added. I can combine this as a floor plan of a specific building, since this is a multi-level floor plan, right? So I can combine this into a single building. For that, I have to go to the building and click action and add new building. You can name the building as anything. I'm just giving Messi apartment. And here you can click add floors, and you can select the floor plan of the two floors you just added and click add floor here, and it will get added. Okay, and between the floors you can select what would be the decibel in between the floors. Okay, currently it is showing as office. I leave it as office. And here there is a action button. If you can click, you get an option like add floor above or below, or remove floor. Okay, this is not needed at the moment, so I am leaving as it is. And as soon as you load the floor map in Ekahau AI Pro software, the first thing you have to do is add the scale. You see a red indication here in add scale, and the reason is the scaling is not completed. If instead of adding the floor map as a PDF or JPEG, if you add the floor map as a AutoCAD file, there will be a option where the scale can be read from the AutoCAD file information itself by the Ekahau AI Pro application. Okay, and in our case, it is just a PDF file and there is no scaling information available. So I am going to start the Wi-Fi design from scaling. Okay, To reduce the length of the video, I have already set the scalings on both floors. And the next thing we have to do is to set alignment points. Alignment point is necessary for 3D network planning, and it greatly helps to allow the floor map scaled and related in a similar pattern. For example, if you're doing it for a multi-store building, the floor plan are going to be the same. And if you set the alignment points for each floor, it would be easy for Ekahau AI Pro software uh, to give the 3D visualization and the 3D network planning. Okay. Uh, for alignment points, minimum 2 points to maximum three alignment point is needed, and it is advisable that it shouldn't be in a straight line for best results. Okay. Now I have already drawn the walls for the floor maps, the wall concrete and the orange one or the dry wall. The attenuation value for dry wall is lesser than the concrete wall, and this is window thick, which is again 3 decibel. So the decibel value changes as you select the medium in the construction site. Since this is a multi-storied building, we have designed the floor two. We have drawn the floor two and drawn the alignment points, everything, scaling has been completed. We don't have to repeat the same process again in floor one. We can just copy like this, and it will copy the entire walls and alignment points, and we can simply paste it here. So it will fit as in the previous floor. Okay, you can verify that, and the aligned floor errors will, if I undo the paste, it is showing align floor error, and if I just paste it again, the align floor error will go off. Let me do that again. Going to paste the wall and the alignment points, and it changed to OK here. As you can see, the floor 2 is OK, and the align floor errors are gone off. Okay, that's the best part of it. By whenever you do for a multi-story building, same process will follow for all the floors in most cases. Okay. The next thing we are going to do is to set the requirement area. Okay, requirement area is necessary for you to identify where the Wi-Fi coverage is actually needed, and for the AI auto planner in the Ekahau application itself to give you better visualization on which place the Wi-Fi connectivity is attained and which place is not covered with the Wi-Fi band, either 2.4 GHz or 5 GHz. In this case, there is a OTS area. Okay, this should be an exclusion area in my current design. Okay, because I don't want any Wi-Fi coverage to be available in this specific area. So I'm going to exclude it. If I am not going to exclude it and include everything as a requirement area, the software, the Ekahau software itself consider this as a requirement also. So suppose if only one access point is enough to cover this entire unit, you might require another access point to cover the OTS area also. So you have to be precise on which area is the requirement area for your Wi-Fi connection and which area you can exclude. Now that I have selected the exclusion area and the requirement area on, okay, only the exclusion area is selected here. I am going to draw the requirement area in floor 1 also. Just give control and drag it to the position where you want. And from here to here. Now we have selected the requirement area and exclusion area. The next thing is we have to select simulated access points. So for this application, they have a wide range of vendors access points added in this icon, and you can select the required vendors, or you can search for the access point you are looking for. And if it is not there, you can ask Ekahau or mail Ekahau to include the access points you are looking for. They are doing it. And in our case, I am selecting TP-Link EAP 320. It supports 2.4 GHz and 5 GHz. Okay, and it supports dual band Wi-Fi connectivity, and this is the access point being used in my unit. So I'm going to add the TP-Link and see how the coverage would be here. Okay. The access point is actually here in my unit, so I'm going to place it exactly here. So if you can see, one access point itself is enough for my Wi-Fi connectivity. Okay, one access point itself is enough for my Wi-Fi connectivity, and it gives a better range to all areas. It gives a better range to all areas. Okay, and if you can see, the signal strength is -61 when I dragged it to the yellow position, and the Ekahau best practice is the signal strength should be below -67. Okay, and you can see there is only two channels enabled in this access point. The first one is 2.4 GHz and the second one is 36. One represent 2.4 GHz and 36 represent 5 GHz. Okay, and the signals visualization, we have selected signal strength, and if I go to floor 2, it is if I go to floor 1, it still shows some signal strength, because from floor 2 the signal propagates the medium. There is a medium which with 30 decibel attenuation value, which is the concrete, and still the connectivity flows from floor 2 to floor 1. As you can see, the yellow coverage visualization, that is the propagation of Wi-Fi connectivity from the access point in the second floor. Okay, so you can so in second floor I am going to add another access point, and let's see how the connectivity is showing here. When I add the second floor access point, it is showing all green, and this is first floor access point and this is second floor. So the connectivity seems very good, and in network area, I have selected 2.4 gigahertz. Okay, 2.4 gigahertz covers a wide length compared to 5 gigahertz. As you can see in the diagram, the yellow line has been shortened, right? And 5 gigahertz support very shorter distance but high speed. But 2.4 gigahertz support longer distance but lesser speed compared to the 5G. Okay, that is the quick band selection, which give you a better visualization where the 2.4G will cover and where the 5G will cover. For me, 2.4G covers my entire unit, and it is lesser than 67 decibel here, and it has a very good coverage for a single access point. And if I select 5G, the connection was dropped down, but still I can access 5G, but not as good as 2.4G. So I selected access point 1 in floor 2, and I can see the connectivity is still propagating in floor 1. And if I go to floor 2, it is not showing the signal prediction because I selected only the current floor. Okay, if I do the same in floor 2, I won't see the signal prediction in floor 1 because I changed the signal prediction to current, and the plus or minus one floor indicates the previous settings we had. Like if you select the previous floor, it will just show the signal prediction plus or minus one floor, and there is option for plus or minus two and all floors. Okay, if you select all floors, you can check the signal prediction of each access points. Okay, and there are a lot of visualization option available here, and this one is specific to signal prediction, and there is another one called secondary signal prediction, where for redundant purpose, if you add another access point, and you can check whether if first access point goes down, whether the second access point will give you proper coverage on the requirement area you selected. Okay, if this access point goes down, you can place another access point to check whether the redundancy is working or not. Okay, and we have couple of other options as well. We have other options as well. Apart from signal strength, there is signal to noise ratio is there, channel interference is there. If you have multiple access points within the requirement area, there should be possibility for channel interference. Okay, and you can avoid that by checking the channel interference graph. Currently, I have only one access point in each floor. It is showing green in both the floors. And if you have channel interference, you can select channel planner, where the Ekahau software itself will auto create or automatically assign the channel, the non-overlapping channel for you. Okay, for example, here 1 represent 2.4G and 36 represent 5G, and in the second floor also it is using the same channel. Okay, and if I select the channel planner, I can select what is the frequency band I require, and there is an option for disabling unnecessary 2.4 GHz radios. That is on by default. Okay, if you want to turn off, you can turn off, or you can leave as it is, because in 2.4 GHz there is limited non-overlapping channel, right? The recommended non-overlapping channel is 1, 6, and 11 as mentioned here, and that is selected there. And for 5 GHz, the first line or the recommended non-overlapping channels 36, 40, 44, and 48, and the width I would select 20 megahertz. The 6G is not applicable in this type of access point, so none of the channel is selected, and I give OK, and this AI will automatically assign the channel to avoid channel interference. You don't have to do anything. That is a cool feature in Ekahau AI Pro software, and as you can see, the channel for 2G and 5G has been changed, and it avoids channel interference between the access points. Now that we have seen the channel planner, there is another AI enhancement is there, that is called AI Auto Planner, where you can select this option to automatically assign an access point in every requirement area you selected. And once I select the access point module, it is automatically taking the access point I added. I leave as it is, and I give advanced option here. You can set the transmit power for each bandwidth, and also you can set the antenna height from the floor level. For example, the antenna height for your residential building and warehouse may differ, so you have to set the correct antenna height. Then comes the area. We have two area, right? Area one is for floor one, and area two is for floor two. And you can set the number. Here you can modify the area visualization colors here, and coverage profile. Currently, it is in Ekahau best practice. There are several other profiles also available. You can select any of that, or you can add a new coverage profile. And device section, you can add how many device it is going to cover in that area. So let's check the file menus options. There is new, open, save as, and also you can import Ekahau Cloud Save. You can save your project in the Ekahau Cloud and open it anywhere, and you can export and import files. And in edit option, you can undo, redo. And in actions, we have AI, auto planner, channel planner, etc. And in view, there are a lot of options here. You can unselect any of the available options to avoid contradiction in the visualization of this application. So you can uncheck access point or areas so that it will not be available in the visualization area. Okay, and if you move to the next option, next is map. We can add map, rename map, duplicate map, swap, and projects. There is a coverage requirements, device profile, usage profile is there. Coverage requirement a moment ago we saw, right? In the AI auto planner, we can call coverage requirements profile, and this is where you can set the coverage requirement profile, usage profile, and the device profile. Okay, and if you simply create coverage profile, this is the Ekahau best practice, and for each criteria, signal strength, secondary signal strength, Ekahau best practice is minus 67 dB for 2.4 gigahertz and 5 gigahertz and 6 gigahertz. And for secondary signal strength, you can turn off the 2.4 gigahertz because it has a very less non-overlapping channels, right? So it is not a recommendation from Ekahau. There is device profile. There is a default profiles available. If you want to add anything, you can click add, and there are a lot of profiles, and each device uses what kind of bandwidth it says, and the technology, the max supported bandwidth, and offset values for 2.4 GHz and 5 GHz. And band selection is automatic here. And the next is usage profiles. So every device you add, how much usage will be there for that device is where you can set. This is where you can set that option. And after that, we have measurement, adapter and channel measurement. I'm not sure what that it is. And in reporting section, we have a special feature called one-click reporting. Okay, if you click this one-click reporting, whatever design you have created, it will generate a report with the option to change the title of the report and the bandwidth selection, what kind of bandwidth you want to see in the report, and the document format would be docs and PDF format. These are the two options available for generating the report. It will take some time for generating this report, almost 5 to 10 minutes, or based on the complexity of the design or planning you have done in the floor maps. Okay. So this is a quick overview about the Ekahau AI Pro software. If you want to dive deep into it, you might require to attend their training session for 4 days, followed by an exam on the last day. And the exam is pretty much easy, and if you just complete their training session fully with the hands-on experience in the practical and good in theory, then you can very well clear the exam. I can help you to practice well for the exam by checking this one in Google. Just search for Ekahau Design MCQs, And here in the Ekahau portal itself, there is a objectives of the multiple choice exams. This will just give you a breakdown of the questions that you may get in the multiple choice exam for the ECSE design. And these are all the knowledge domains and the percentage of mark from each topics. And they have split up further what are the entities that covers in each domains. In Ekahau tools and methodology, they have their own tools, AI Pro, Connected Sidekick, and standards and regulations. What are the regulatory bodies? Wi-Fi Alliance, what is IEEE, and what are the IEEE 802.11 standards, and what are the different types of 802.11 protocols, and which one is used for 2.4 gigahertz and 5 gigahertz, and many like non-overlapping channels on all the bandwidths. You can study those, and the RF fundamentals, radio frequency fundamentals. They have split up the topic like sine waves, wavelength, amplitude, phase, noise and SNR, inverse square law, free space path law, etc. And there is modulation and spectrum. And different types of modulation we have the BPSK, QPSK, and 16 QAM through 1024 QAM. Understanding 2.4 GHz, different bandwidth channels they have mentioned. Yes, that is pretty much about it. If you just go through all this topic, you can easily clear the exam. And it is recommended to attend their training program to get cleared in this exam. And if you attended their training session completely, thoroughly, then it is very easy to clear the exam. I Once again, I wish you all the very best if you're up to clearing the ECSE design exam. And also, there are different types of exams and trainings available for ECSE Advanced, ECSE Troubleshooting, and ECSE recertification. Because the certification which you are going to acquire will be valid for 3 years from the date of exam you appeared, and you might need to recertify for the ECSE design advance or troubleshooting that you have taken before. Thank you all for watching this video, and if this video is informative for you, I request you to subscribe and stay tuned for my channel's update. Thank you. Have a nice day. Bye bye.